Okay, so this section is all about rational functions. So rational functions are any time you have a variable in the denominator. So you can still have variables in the numerator, but anytime you put a variable in the denominator, that makes it a rational function. So you're going to be able to find a domain, your asymptotes, which you could have vertical, horizontal, and slant. Slant we'll talk about tomorrow. So domain is all your real numbers except whatever makes the denominator 0, because you can't divide by 0. Okay, so that makes your vertical asymptote. Asymptote is a line that a graph comes close to. So vertical will be this line that the graph comes close to, but it's never going to cross. Horizontal asymptote, which will be a y equals a number. That's your horizontal line. Graph will come really close to, but it's never going to cross. Vertical is your exception in the domain. So if you find your domains all reals except 2, your vertical asymptote would be x equals 2. For your horizontal asymptote, you have 3 rules, and it's only going to apply to one of the options. You have 3 of them to pick one. So if the degree means the highest exponent is on the numerator is greater than the degree in the denominator, that's none. And that's what we're going to talk about with the next lesson with slant asymptotes. If the degree in the numerator is less than the degree in the denominator, then it's y equals 0. And if they're the same, LC stands for leading coefficient. So you would divide the leading coefficients. Okay, so we're going to do 3 examples. Okay, now your book is going to ask you for more parts than I'm going to ask you for. So what I'm going to ask you for is I'm going to ask for the domain, your vertical asymptote, and your horizontal asymptote. Okay, and I'm going to label them. Domain will be my D, vertical asymptote will be VA, and horizontal will be HA. If you want to write out all the words, be my guest. Okay? So your domain is all reals except whatever makes the denominator equal to 0. So I would just set your denominator equal to 0 and solve. So I'm going to subtract 2. So I have x equals negative 2. So my domain would be all reals except negative 2. Okay, which means my vertical asymptote is the exception in the domain. Vertical lines are always x equals. And my exception in the domain is what I just found. So my vertical asymptote is x equals negative 2. Okay, then I look at my 3 options. For the horizontal, look at the degree. If there's no x, then that means the degree is 0. So the degree in the numerator on this one is 0. The degree in the denominator of this one is 1. So the degree on top is less than the degree on bottom. So that means your horizontal asymptote is y equals 0. Okay, then we're going to go to graph it. I'm not going to make you find the intercepts. I'm not going to make you find all the other continuing points, whether it's discontinuous or continuous. These are the 3 things I want you to find. I'm going to look at your little T-chart and then we're going to graph. So on your T-chart, if you just have one vertical asymptote, which we just have one on this problem, you need to pick a number, 2 numbers above and 2 numbers below. So 2 numbers above would be negative 1 and 0, and then 2 numbers below, negative 3 and negative 4. Okay, we're going to plug those into the original problem and solve. So negative 1 plus 2 is 1. 1 divided by 1 is 1. 0 plus 2 is 2. 1 divided by 2, 1/2. Negative 3 plus 2 is negative 1. 1 divided by negative 1 is negative 1. Negative 4 plus 2 is negative 2. 1 divided by negative 2 is negative 1/2. graphing. Your asymptotes, I want you to make dashed lines. So when I'm graphing, I'll just do everything in different colors. So let's do it in red. Okay, my vertical and my horizontal, whatever they are, I'm going to make them dashed lines. So my vertical is at x equals -2, and my horizontal is y equals 0. Okay, and I realize if it's on the axis, sometimes it's hard to make it exact. Do the best you can. Okay, then when I'm plotting these points, first 2 points are going to go together, the second 2 points are going to go together. So when I have -1, 1, and I have 0, 1/2. Okay, those are both connected, or contained, inside these dashed lines. So when they're going to curve, they're going to curve together, but this one's going to go up. It cannot cross that dashed line. Just like when these curve this way, it can't cross this dashed line. They are contained inside those two asymptotes. Okay, just like when I graph these other points, -3, -1, -4, -1/2, these 2 points are contained inside these dashed lines. So when I graph them, they make curves, but they can't touch them and they can't cross them. So they'll get really close, but they're never going to touch or cross. And like I said at the beginning, I'm not going to make you, the directions I think on this say, like, find if it's continuous or find the intercepts. This is all I need you to do. Domain, vertical asymptote, horizontal asymptote, and then graph it. And 2 points on each side is sufficient to make sure you know what the graph looks like. Okay, so first thing I'm going to do is find my domain. So if I set the denominator equal to 0 and solve, so I would subtract 1, x equals -1. So my domain would be all reals except -1, which means my vertical asymptote is x equals -1. Okay, now for this first part, none of them are going to have slants. So your 28 through 38, even on your homework, they're just going to have vertical and horizontal. The slants will be for day 2, which is what you'll be watching for the video tomorrow. Okay, so my horizontal, I look at my degree. Well, I have an x on top and an x on bottom, so the degrees on those are 1. So they're the same, which means I'm going to divide leading coefficients. Leading coefficients are the numbers in front of the variable, highest variable. So I would have 2 divided by 1. So 2 divided by 1 would be y equals 2. Okay, vertical lines are always x equals. Horizontal lines are always y equals. So if I go ahead and draw those on my graph, I have dashed lines at x equals -1. And I have a dashed line at y equals 2. Okay, then my t-chart. In order to graph, I need to pick 2 numbers on either side of my vertical. So my vertical is -1. So if I pick 2 numbers greater, I would have 0 and 1. And then 2 numbers smaller, -2 and -3. Okay, so I plug those in. I'm plugging in for both x's. So on top, that would be 5 plus 0. So that would be 5 over 1. So 5 divided by 1 is 5. If I plug in 1, I would have 7 on top, and I would have 2 on bottom. So 7 divided by 2, 7 halves, which is the same thing as 3 1/2. Okay, if I plug in -2, I would end up with, that'd be -4, so it'd be 1 on top, and that would be -1 on bottom, so 1 divided by -1 is -1. And if I have -3, I would have -1 on top, and I would have -2 on bottom, which would be +1/2. Okay, so if I graph these, I would have 0, 5, and 1, 3.5. So those are going to connect, but they're going to curve, but they're not going to touch these dashed lines. So it curves to here, and it curves up to there. And then I have -2, -1, -3.5. Same thing, these two are going to curve to here, and they're going to curve up to this dashed line. Most of the time, they are going to be opposite diagonals of each other. Most of the time. Sometimes you'll see them side by side, okay? But most of the time, when you have one vertical asymptote, you're going to see them in the diagonals. Okay, we're going to do one more, and this one's going to have 2 vertical asymptotes. Okay, so on the bottom I have x squared minus 4. If I want to find my domain and I set this equal to 0, I would add 4, and then I would take the square root. Well, anytime you solve an equation and you take the square root, you have plus or minus. So that means my domain is all reals except, so now I have 2 exceptions, except 2 and -2. Well, if I have 2 exceptions in my domain, that means I'm going to have 2 vertical asymptotes. I'm going to have x equals 2 and x equals -2. Okay, then for my horizontal, if I look at the degrees, well, they're both squared, so the degrees are the same, so it says divide leaving coefficients. So 1 divided by 1 is 1, so this would be y equals 1. Okay, when I'm graphing my asymptotes, verticals, I have -2 and 2. Okay, when you do your horizontal, the inside part doesn't have a horizontal asymptote. So when you have y equals 1, that dashed line does not exist in the middle. I know it looks weird. This middle part could either look like a quadratic or it's going to look like a cubic. So either a square or a cube. The only way we're going to know is to plug points in. The outsides are going to look like what we just did on 1 and 2. Okay, so if I pick my points, let's just go with the outsides first. So this was -2, so I'm going to put in -3 and -4 first. So I'm going to use a calculator. So if I plug those in for my x's, I would have 9 plus 15 plus 4 divided by... So this would give me 2 1/3. This would give me 3 1/3. I'm not sure I did this one right, so I'm going to replug my -3 in. Don't remember if I divided correctly or not. Nope, I didn't. Alright. So this is 5 3/5. I didn't plug it in correctly. So I would have negative 3, 5 3/5, and negative 4, 3 1/3. So these are going to come close to those dashed lines, but it's never going to cross them. Okay, then if I do my total other side, so now I'm going to plug in positive 3 and positive 4. So if I plug in positive 3, I would get negative 2/5. And if I plug in positive 4, I get 0. So I would have negative 3, negative 2/5, and then I would have negative 4. Oops, I didn't put that point right. So negative 3, negative 2/5 right here, and then and then 4, 0. So then these curve like that. Okay, now for the middle, we don't know what it looks like until we plug those numbers in. And I ran out of space on my T-chart, so I'm just making another one. We're going to plug in all those points to figure out what it looks like. If it's going to look like a quadratic or like a cubic. So I'm going to put in negative 1, 0, and 1. And there's no way to know without plugging them in. So if I put in negative 1, I'm going to get negative 3 1/3. Okay, if I put in 0, I'm going to get negative 1. And if I plug in 1, I'm going to get 0. So I have negative 1, negative 3 1/3, 0, negative 1, and 1, 0. Okay, since those are all going up, that's going to look like a cube. So if they're all kind of trending up or all trending down, those are your cubes. If it starts up, then goes down, then back up, or down, up, then down, those are going to look like a quadratic. Okay, this should be able to get you through 28 through 38 on the 194 assignment. Once again, domain, vertical, horizontal, and graphing is all you have to do. You can ignore the rest of the directions unless you want to do that part.